Dear students, welcome to ECA1 class. Today we are going to solve an example of mesh analysis using inspection method. Let us consider a circuit in which we have three meshes and we have to find the mesh currents I1, I2 and I3 using inspection method. Now first we consider mesh 1 and write the equation for that mesh. For mesh 1, the inspection method is sum of all the resistors around mesh 1 multiplied by the current of mesh 1 minus sum of all the resistors between mesh 1 and mesh 2 multiplied by current of mesh 2 minus sum of all the resistors between the mesh 1 and mesh 3 multiplied by the current of mesh 3. Now we have only three meshes, so we conclude our formula here, which is equal to sum of all the applied sources in mesh 1. Now we write these values as sum of all the resistors around mesh 1. We have R2 and R4. There is no other resistor in mesh 1, so we write here R2 plus R4 multiplied by the current of mesh 1 minus the sum of all the resistors between mesh 1 and mesh 2. So we see that there is only R4 which is common between mesh 1 and mesh 2. So we write here R4 into I2 minus sum of all the resistors between mesh 1 and mesh 3. So from the figure we see that R2 is the common point or a common element between the mesh 1 and mesh 3. So we write that R2 into I3, which is equal to sum of all the applied sources in mesh 1. So we see that we have only one source present in the mesh 1, so we can write here E is the only applied source in mesh 1. So this is basically the equation for mesh 1 for the given circuit. Now consider mesh 2 and write the equation for mesh 2. Mesh analysis inspection method states that for mesh 2, sum of all the resistors around mesh 2 multiplied by I2. Now we are taking mesh 2, it means the current of mesh 2 is with positive sign minus sum of all the resistors between mesh 2 and mesh 1. Now we are comparing mesh 2 with mesh 1, so we can write the equation, the value of the current is I1 minus sum of all the resistors between the mesh 2 and mesh 3 multiplied by I3 because we are comparing with mesh 3. Now we have only three meshes, so we conclude our formula here, which is equal to sum of all the applied sources in mesh 2. Now substituting the values in this relation, we see that sum of all the resistors around mesh, sum of all the resistors around mesh 1, this thing resistor around mesh 2, sorry, is equal to, we have R3, R5 and R4 around mesh 1, so we can write it R3 plus R4 plus R5 multiply by this I2 minus sum of all the resistors between mesh 2 and mesh 1. So from figure we can see that only we have R4 is common between mesh 1 and mesh 2, so we can write here R4 into I1 from the formula minus sum of all the resistors between mesh 2 and mesh 3. So we can see that only R3 is the common point between mesh 2 and mesh 3. So we can write here R3 into I3. I3 is basically this value is equal to sum of all the applied sources in mesh 2. Now from figure we can see that there is no applied source in mesh 2, so we can write here is equal sum of all the applied sources in mesh 2 is equal to 0. This is equation 2 for mesh 2. Okay, now we can write the equation for mesh 3. I3 is the current of mesh 3. So using inspection method, sum of all the resistors around mesh 3 multiply by the current I3. Now you can see that we are taking mesh 3 as a reference, so it's the current of mesh 3 is positive, minus sum of all the resistors between mesh 3 and mesh 1 multiply by the current of mesh 1, because we are comparing mesh 3 with mesh 1, minus sum of all the resistors between mesh 3 and mesh 2 multiply by the current of mesh 2, because we are comparing mesh 3 with mesh 2. Now we can substitute the values of these values into this equation. We get sum of all the resistors around mesh 3. We have R1, R2 and R3 around mesh 3. So we can write here R1 plus R2 plus R3 multiply by I3, current of mesh 3, minus sum of all the resistors between mesh 3 and mesh 1. So you can see that R2 is the only resistor between mesh 3 and mesh 2. So we can write here minus R2 into I1. Now for the third, sum of all the resistors between mesh 3 and mesh 2 multiply by I2. So from the figure, from the circuit, you can see that there is R3 which is common between mesh 3 and mesh 2. So we can write here minus R3 into I2. Now we don't have any other loop, so we conclude our relation here is equal to sum of all the applied sources in mesh 3. Now from the circuit you can see that there is no applied source in mesh 3, so we can write here sum of all the applied sources in mesh 3 is equal to 0. This is your equation number 3 for mesh 3. Now we have these three equations: equation number 1 for mesh 1, equation number 2 for mesh 2, and equation number 3 for mesh 3. You can solve these three equations by any method studied in the calculus to get the values of I1, I2 and I3. You can solve this question using detailed method. You will see that you will get the same number of equation from that method also. That's all. In case of any confusion, drop your question in the comment box and I will answer it. Thank you very much.